This video will be about completing the square. So when you're completing the square, it's one way to solve a quadratic. A quadratic function is something that looks like this: ax squared plus bx plus c. And when we're solving it, it has to have an equal sign, so equal to 0. And the purpose of the completing the square is that when you have something like this, x squared minus 5x plus 10, we can't just solve it using our normal methods. We can't just do opposite operations. There's a lot more steps to it, because with this x squared, it makes it a lot more complicated. So let's say we have x squared minus 12x equals negative 5. So when we have this, for completing the square, we actually want all the variables on the left and just the numbers on the right. So we're actually okay with how this is set up. We have our variable x squared, our variable negative 12x on the left side of the equal sign, and negative 5, the number on the right side. So that is actually set up fine for us. So now we need to figure out, and I usually write in a blank spot to help me remember, okay, this is what I'm going to be figuring out. I need to figure out a number to put here so that when I factor this left side, the two factors match. This has to be x minus the same number, x minus the same number. These should match. So there's a very specific process that will help us find that one specific number that would then let us factor that to match. So the reason I put a blank on both sides though is because if you add something to the left side, you're also going to have to add it to the right side. So I'm going to erase this to give me room. So here is the process you have to follow in order to find that number. We take this middle term, b, and we divide it by 2, which means negative 12 divided by 2. But then we're not done after that. After that, we're going to have to square what we get. So according to order of operations, I do what's inside the parentheses first. Negative 12 divided by 2 is negative 6. Then I square it. Negative 6 squared means do negative 6 times negative 6, which gives us positive 36. So we get x squared minus 12x plus, then we're going to fill that blank spot with positive 36. And what we did to one side, we have to do to the other. We also have to add 36. So on the right side, we just combine. Negative 5 plus 36 is 31. On the left side, we need to factor. Something like this, when we factor, we want numbers that times to be 36, but also add to be negative 12. Now I also said that they need to match. So specifically, we want numbers that multiply to be 36 that match. Like I can say, oh, 3 times 12 is 36, but 3 and 12 don't match, so they're not going to be useful to us when we're completing the square. So 6 times 6, those match, and they match and equal 36. Or negative 6 times negative 6, those match, and they equal 36. So we want the middle number to be negative 12. If I check the first one, 6 plus 6 gives me positive 12. That means it didn't meet the second requirement. We can't use those numbers at all. So now I do negative 6 plus 6, that gives me my negative 12. And now I can put this in my parentheses. It always starts with x, because to get x squared, we have to do x times x. So we have one of the x's in each parenthesis, and then minus 6 minus 6. We found the numbers that matched. So if they match, we can rewrite it as x minus 6 squared. The reason we did that is because now that we have it as squared, we can do the opposite of squared. The opposite of squared is to square root. So the squared piece and the square root piece cancel each other out, and the parentheses will actually go away at this point. They're not necessary anymore. On the right side, we have square root of 31. Now when we're square rooting and we're solving an equation, we need to remember now that we include a plus or a minus. Because a positive 6 is, not a positive 6, a positive number is possible and a negative number is possible. So we have to include both possibilities. So we're not quite done yet. We need to still get x completely alone. We need to do the opposite of minusing 6, which is adding 6. Now because this is a square root, I can't actually combine them together. So standard math notation is to put this number without the square root first and the number with the square root second. We should also check to see if square root of 31 would reduce, and we do that by doing a factor tree. We need to say what numbers multiply to be 31. Well, the only possibility is 1 and 31, and we don't care. The 1 is not important to us in a factor tree, so that didn't work out. That was our only possibility, and it didn't work out for us, so we leave it as 6 plus or minus square root of 31. So let's try another one. So on this one, it's equal to 0, but we learned with completing the square that all the variables should be on the left, all the numbers on the right. So our first step is to get all variables on the left and all the numbers on the right. I know that looks like a hashtag symbol, but it was originally meant to represent number. So that is numbers on the right. So x squared, equal sign, now we have left side, right side. X squared is on the left. We're okay with where the x squared is at. Negative 10x, it's on the left. We're okay where that's at. 29, it's on the left. We're not okay. That's a number. We need to move it to the other side. So we bring stuff down. We get x squared minus 10x. The 29's cancel. We get equals negative 29. So now step 2, we're going to put in that blank spot so we remember what we're trying to fill. X squared minus 10x plus blank spot. Negative 29 plus a blank spot. Okay. Step 3 is to fill the blank spot using b divided by 2 all squared. So b was that middle number again. It's the number after x squared. So negative 10 divided by 2 squared. We divide first. Negative 10 divided by 2 is negative 5. Negative 5 squared is positive 25. So we're going to fill the blank spot with positive 25. So we get x squared minus 10x plus 25 equals negative 29 plus 25 is negative 4. Okay, our next step is to factor, and we want the factors to match. So we want the factors should match. So we want numbers that multiply to be 25 and add to be negative 10. Well, 25 can be 5 times 5 or negative 5 times negative 5. We want a negative 10, so it's got to be our negative options. So we get x minus 5 times x minus 5 equals negative 4. Since we have two of the same thing, now we rewrite as it's called a perfect square binomial. So we want to rewrite it with squared. x minus 5 to the second. Now we should square root both sides. We know the 2 cancels with the square root symbol and the parentheses go away. We know it should always be plus or minus square root of negative 4. I'm going to get x alone now, which means I have to add 5 to both sides. So we get x equals, and again we put the number first, the square root second. X equals plus or minus square root of negative 4, and our last step is simplify the square root. So we can simplify the square root using a factor tree. And then the negative puts in its own little twist. When you have a negative sign under a square root, we can't actually take the square root of a negative number, so we call this an imaginary number. In front of the radical, we would put an I. So this changes to an I out front. Okay, now we need to factor 4. 4 is 2 times 2. Now a factor tree, I could try and factor further, but I'd get 2 times 1, which we said 1 is not important to us on a factor tree, so we don't use those. So 2 times 2, that means when we have a group of 2 that are the same, one of them cancels out and one of them will move outside of the radical sign. So we have I outside the radical sign, we have 2 outside the radical sign. Well, here we don't have anything left inside because one of the 2's canceled. This 2 moved outside. The 4 we don't use anymore because it changed to the 2 times 2. So we actually just leave I2, we get rid of the radical symbol now. And also usually we put the I behind the 2 because we put the variable after the letter. So I know this process is pretty complicated. There's a lot going on. So we have one last example, and that's when we have a number in front of x squared. That can make things more complicated. So following the process we did before, though, we need to check and make sure that the variables are on the left, the numbers are on the right. Well, 32x is on the right, so we need to move it to the left, which means we're going to have to minus 32x from both sides. We have 4x squared minus 32x equals 17 over 4. At this point, we'd normally go to the blank spot step, but we cannot do completing the square if there's a number in front of the x squared. So we're going to have to add in an extra step, and that is to divide everything by the number in front of x squared. That would give us, sorry about that, that would give us x squared minus 32 divided by 4 is 8x. I'm going to go ahead and put in my blank spot for our next step. 17 divided by 4 again would be 17 over 16 plus another blank spot. So now we go through and do that process where we use the b divided by 2 squared. B is negative 8 divided by 2 squared. Negative 8 divided by 2 is negative 4. Squared is positive 16. So we get x squared minus 8x plus 16 equals. Now in order to add these together, I need them to have a common denominator. 16, we can put it over 1, but we would have to multiply top and bottom by 16 in order to make the bottom match the first fraction. So 16 times 16 is 256. So we have 17, and this is separate kind of side work. 17 over 16 plus 256 over 16. Adding those together, 256 plus 17 is 273 over 16. Now we can factor that left side. Things that multiply to be 16 but add to be negative 8 would be negative 4 and negative 4. We rewrite it as a perfect square binomial. We get rid of squared by square rooting. So we get x minus 4 equals square root of 273 over 16. Then we should check and see if that fraction reduces at all, which I don't think it will. It does not. Also, we use plus or minus since we're working with an equation, and we square rooted. Now we do the opposite at the end and add 4. So we get 4 plus or minus square root of 273 over 16. Now we're not quite done because we can simplify this a little bit. When you have a fraction, you can square root each part individually. I can say square root of 273, square root of 16. 16 is a perfect square, so we know the square root of 16 is 4. That's the only number multiplied by itself that makes 16. Except for negative 4, but we already have our plus or minus sign involved. So this would be our final answer.